based. Next, I'd like to introduce Assistant Professor at the Goldman School, Hsiang, who focuses on how policy can encourage economic development while managing global climate change, how natural disasters impact societies, and the effectiveness of policy responses, and how environmental conditions influence social instability and violence.
Great. Thank you very much for this opportunity. So far today, we've spoken a lot about how we are affecting our environment. And what I want to talk to you about now is a lot of emerging work where we're trying to understand better how the environment affects us back in return. So about a year ago, I started this project with two other members of UC Berkeley, Marshall Burke and Ted Miguel, where we were asked to go out and examine to what extent is there quantitative or statistical evidence that climatic conditions affect human conflict or different types of social instability. Now, there are many reasons why climatic conditions might affect instability. A lot of ideas have been put out there by theorists. If you look through history, there's a lot of stories that can be told. I won't go through all of them, but sort of some of the salient arguments are, for example, that climatic conditions can adversely affect economic conditions. And when the economy deteriorates, people's incentive to participate in the productive economy obviously declines. And so the relative incentive to participate in other types of extractive actions, maybe joining a rebel group that promises some likelihood of a payout if you successfully take over the government, might rise. Okay? So there's actually some labor market dynamics here where the climate can influence people's willingness to participate in non-productive activities, things that might lead to conflict. But there's other ideas out there as well. For example, related to what we just saw, it's thought that food price spikes might increase populations' willingness to sort of take to the streets. There are ideas about how the climate can affect underlying inequality within a society, and that can lead to social strife. And there's other arguments about transportation and logistics and populations migrating to cities very rapidly, creating rapid strains on public resources. And then finally, there's actually a really large literature I'll show you briefly from psychology, where we see that people actually change the way they think based on their environmental conditions, and that can in some cases lead to violence. So we were tasked with examining to what extent is there systematic quantitative evidence that there is some sort of linkage between climatic conditions and interpersonal or intergroup conflict. And to sort of do this, my colleagues and I went into the literature and pulled from archaeology, criminology, economics, political science, and we came up with sort of a very rigorous quantitative standard of how studies had to be conducted. We were able to recover 60 studies that met this standard. They were coming from all these different fields, and they represent the collective work of almost 200 authors from around the world. And in a few cases, the studies were not quite up to the statistical standards that we had imposed for ourselves. So we actually contacted the authors of the original study, got the data, and reran their analysis, sort of using these more modern techniques. And so just to give you a sense of what we were doing, so to select different studies, which I will show you, the study has to be quantitative and data-based. And importantly, the study has to follow how populations behave over time. Okay? So to get a sense of why we're doing that, one can imagine, first of all, the ideal experiment we would like to do is we'd like to have two planets, and we would like to heat one of them up and keep one of them the same temperature, and we'd like to observe how social conflict changes in those two. Right? So that's a hard experiment to do. In the absence of that experiment, what people have done in some cases is they've gone to different populations around the world, and they've said, well, one population is in a hot climate, and one population is in a cool climate. Do they have different patterns of violence? Now, that's obviously not quite the right approach, because if we were to look at two countries, say Norway and Nigeria, they have very different climates, but they also have very different geographies, very different governments, very different histories, very different politics. So there's too many confounding variables that we can't plausibly control for. So instead, what we do is we go to a single location, and we follow that population over time as the climate varies. And then we observe how that population's behavior varies to reflect those underlying changes in the environment. And the one reason we do that is that, well, the main reason we do that is so that the population serves as the control and the treatment group for itself at different moments in time. And through that setup, we know that we're accounting for the geography and the politics and the history, because those things are unchanged in this sample. So that's the sort of standard that all these studies have to follow. They have to follow a population. And we were able to obtain basically roughly a dozen studies that looked through deep history. There's a small number of actual experiments where they put people in a laboratory and change their conditions and see how they respond. And then the vast bulk of the studies are these observational studies that look at historical populations and their behavior. Just to give you a sense, this is the first study that really takes a broad look at different types of human conflict. So at all different scales of sort of the conflict spectrum, we go from interpersonal violence, things like crime on the street and domestic violence, to intergroup conflict. These are things like racial riots or civil conflicts, all the way up to full-scale institutional breakdown and the collapse of sort of historical populations. Now, to give you a sense of how the literature stands to date, each horizontal bar on this graph represents a different study that we were examining. And on the vertical axis, you can see the different regional coverage of these different studies. And on the x-axis, you can see the sample of years that the study was examining. Now that x-axis is in a log scale. So on the left-hand side, it goes all the way from 8,000 BC up to the present day. And one thing we see is that in the modern world, we have studies from all around, from every continent. So we have a really large number of studies from Africa, but we also do have studies from the Americas, as well as Eurasia. And then we have a large number of studies in the modern era that are fully global in their coverage. I want to show you a few of the studies just to give you a sense of what the evidence, the current state of the evidence is. So this was a famous study where they wanted to understand whether or not the climate played a role in the collapse of the Akkadian Empire. So the Akkadian Empire was one of the earliest. It occupied what is modern-day Syria. And so what you see here is the orange bar is sort of when we know that the Akkadian Empire collapsed. And the line is showing you a reconstruction of how wet it was in the region based on cores from the bottom of the Sea of Oman just off the coast. And so by pulling up mud from the bottom of the ocean, we can reconstruct what was rainfall like over land, because when there's more rainfall over land, less dust blows over the ocean and settles to the bottom. Okay, so we reconstruct and we found, well, not our team, this Cullen team found that the collapse of the Akkadian Empire was coincident with a massive drying event in the Arabian Peninsula. Now, this is only one study. What we were able to do is actually point out that there are studies from around the world and throughout history where similarly structured evidence exists. Okay, so each vertical orange bar represents a period of either major social conflict, social upheaval. For example, in the middle panel, it was by reconstructing basically the strength of the monsoon in China, it was pointed out that almost all Chinese dynasties collapsed during dry periods, sustained dry periods, and that no new Chinese dynasty was able to consolidate political power until the climate shifted back to its wetter state. Interestingly, the bar one of the bars on the right, sorry, pointer, is the collapse of the Tang Dynasty, which coincided with the collapse of the Mayan Empire on the opposite side of the Pacific Ocean, and it looks like it was a related climatic event which caused drying on both sides of the Pacific Ocean simultaneously. Now, one can ask whether or not this type of evidence has any relevance to us today. These populations existed many years ago when technology was very different. Populations tended to be poorer than the global average. However, we do point out that some of these populations that we're observing have a resource base or an access to resources that is similar to many populations around the world today. Okay? So if we were to look, for example, at the collapse of the Mayan Empire, we would find some countries in Africa have per capita incomes that are roughly the same, according to current estimates by economic historians. So obviously, populations in Niger or in Chad live in a world where the technological frontier is far beyond these historical populations. But one important question we have to ask ourselves is whether or not they really have access to all those technologies and whether or not their resource base might be more comparable to these historical societies. Shifting gears a little bit, I'll just point you to a couple very interesting sort of experimental psychology studies. So these are studies conducted by psychologists. In the first one, it seems a little bit silly. So what they did is they basically went to a parking lot in Arizona, and on weekends, one of the researchers would go and park a car in a place where there's only one lane, and wait until a second car pulled up behind them, And then when the light turned green, they would do nothing. They would just sit. And they would wait for the entire 12-second green light cycle. And the researcher in the bushes would sit there with a stopwatch and time how many seconds out of that 12-second cycle the guy in back was honking his horn. Okay? And the result is right here so what you see is on the y-axis, it's the time spent hawking. On the x-axis is a measure of temperature on the day of the experiment. They did this every weekend throughout the summer in Phoenix, and what we saw is that individuals tended to behave more aggressively to a complete stranger on hotter days. Now, in a slightly more serious example, a research group in the Netherlands took police trainees and placed them in a training exercise in an enclosed room where they were confronted with a video of an assailant approaching them with a crowbar. And they had to make a decision about how to respond. This is actually a standard training exercise for these policemen, but some of the individuals were put in hot treatment and some of them were put in a very comfortable room. And what was observed is that the police officers put in the hot room were more likely to take an aggressive posture and more likely to draw or fire their weapon. Okay? And so they were debriefed afterward, and they all took a survey, and the researchers concluded that it seemed like the most likely reason why the policemen in the hot treatment were more likely to employ violence was because they actually felt more threatened given the same stimulus. Okay, so they reported feeling like their life was in greater danger than the individuals in the cooler treatment. And so this suggests that there's something very deep and psychological about how we interpret one another's actions, and that those interpretations can be conditioned by our environment. Finally, like I said, the vast bulk of the research is coming from historical observational studies where we have data on what happened to different populations and where that data is matched to sort of social outcome data. So I'll just point out a few so you have a sense of what those studies look like. In a very important 2004 study, my co-author and his colleagues pointed out that civil war in African countries was much more likely in years when rainfall was declining. And at the same time, it was pointed out that the GDP of these countries was also declining in those years. And so they suggested that maybe it was the decline in rainfall that led to a decline in GDP that led to an increased likelihood of civil war in these countries. Now, those researchers, in conjunction with my other co-author, then revisited that study 5 years later, and they actually included information about temperature and found that actually high temperatures were a more important predictor variable, and that high temperatures were actually playing a more significant role in elevating the risk of civil war in these countries. I was not working with these co-authors at the time, but with some of my colleagues at Columbia, we were able to actually extend this work further and point out that the state of the global climate seems to be an important predictor of the rate at risk which civil conflicts around the global tropics are being initiated. And then to give you a sense of what that looks like, so the way we were able to do that is we were conditioning the likelihood of conflict on the El Niño Southern Oscillation, which is the dominant mode of the global climate on a year-to-year basis. And so when an El Niño event occurs, what happens is that in the Pacific Ocean, a tremendous amount of thermal energy is released from the ocean into the atmosphere, and then it produces a large equatorial Kelvin wave that propagates through the tropics, leading to warming and drying throughout the tropical band. This lasts for several months and then dissipates towards the end of the year. And so what we did is we tried to identify those locations that were getting hit by that large atmospheric wave propagating around the equator. And here those are marked as sort of the blackish, reddish pixels that are labeled teleconnected. And so what we did is then tried to understand on a year-to-year basis, when the Pacific Ocean became warmer and created that large wave, did the tropical band, the red tropical band generate more civil conflicts? And so what we have here is on the x-axis, we have basically the state of the Pacific Ocean, the equatorial Pacific, and on the y-axis is the risk that a randomly selected country begins a new civil conflict in that year. And what we see is that as we shift from the cooler and wetter La Nina state on the left to the hotter and drier El Nino state on the right, the risk of civil conflict throughout the equatorial band effectively doubles from 3 to 6%. Now, the blue line here is labeled weakly affected. Those are the countries that are too far north or too far south to be hit by that large equatorial wave. So in a sense, that's like our placebo group. And we see they weren't getting hit by this large wave, and we see no signal in terms of the likelihood of civil conflict in these countries. So that's a global result. And I've just plotted here for you those same pixels in green on the top panel and sort of the same response that I was just showing you for the tropical band in the lower panel. That's a global result. But what's been really exciting about this study is that by looking at so many different studies from many different researchers, we've been able to point out that there are other studies that looked at just Africa at the country scale. There was an important nested study that looked at pixels just within East Africa. Sorry, going backwards. And then there had actually been another study looking just at Tanzanian villages. And so this map on the left is actually a plot of all the villages just within a single pixel in the second to left plot. And throughout all of these sort of scales of social organization, all of these different spatial scales, when we look at how societies respond to fluctuations in their environment, we tend to see similar patterns. So in general, a shift towards higher temperatures or towards more extreme rainfall events tends to elevate the likelihood of social conflict at all of these different spatial scales. There's actually more examples than just Africa, though. This is not a strictly African phenomenon. So on the left here, I'm showing you a result from sort of pixels within just Kenya. We see that as temperature rises, the likelihood of political and intergroup violence is rising at the local level in Kenya, but it's also observable around the world in other contexts. So for example, the top middle panel here, we're showing here that sort of the likelihood of farmers to invade one another's property in the Amazon basin rises when the rainfall is either too high or too low. And those are the types of events that cause a collapse of the farmer's income, basically because crops do so poorly. In India, rainfall losses are associated with an increase in Hindu-Muslim riots at the county level. In the United States, there's very high-resolution data on a variety of different crimes. And what we see is that across basically all counties within the United States, an elevation of temperature leads to higher rates of violent crime in basically a linear fashion, including this is a recent study by Ranson, very important. They point out that many different subtypes of crime, including rape, increased with increasing temperature. And then in the last panel, this is a very interesting, amusing, but important study. They actually were examining every at-bat in Major League Baseball in the United States. Sort of an incredible data set. And so what happens in baseball is that sometimes the pitcher will hit the batter with the ball. This is a very violent act. And what happens is, you laugh, but these guys are throwing the ball like 100 miles an hour. And so what often happens is that if I hit your batter with the ball, you, when we switch sides, will retaliate and hit my batter with the ball. And so this is a very frequently observed type of exchange, sort of a form of intergroup violence. And what they find is that the likelihood of retaliation, conditional on you hitting my batter, increases dramatically with the temperature on the day of the game. Okay? So this is important because it indicates that there's a tie, a linkage between interpersonal violence and intergroup violence that can be conditioned on the environmental state. So we can escalate. We have escalation from interpersonal conflicts where I drag in my buddies and they start fighting on my behalf. So we've looked at 60 studies. I haven't shown you all of them, but sort of the take-home messages are we observe associations between climate variables and human conflict across all major regions of the world, across all periods of recorded human history, at all different scales of human organization, at all different spatial scales, and at all different temporal scales. So we actually observe that whether it's an anomalous hour, an anomalous day, an anomalous week, a month, a year, a decade, and in some cases there are studies that have even pointed out that over anomalous centuries, populations are more likely to experience this type of upheaval or different forms of conflict. And so it's not as though slower changes are necessarily easier for populations to adjust to. There are many reasons to think why slow changes are actually harder to adjust to. For example, you use up all your reserves that you've stored to get you through the tough times. To give you a sense of what's going on, so the global relationship that we're sort of able to uncover is something we call U-shaped. So basically, if we have very high rainfall, very low rainfall, those tend to both be very bad for agriculture. And we also observe that those tend to lead to higher incidences of different types of human conflict. Similarly with temperature, if we increase the temperature of a population that's already quite warm, we observe higher rates of conflict at all these different scales. And if we go far enough back in time to where we're in populations that are basically in a cold epoch, in a relatively cold or temperate region, we observe that cold events also tend to increase the likelihood of conflict. But in the modern world, it looks as though most populations are already warm enough that they're on sort of the warm side of that U-shaped relationship. An important part of this study was that we actually also tried to standardize results across many, many different communities. And I will only point this out for a moment, but basically we want to pin down a number. For policy purposes, we want to really get people thinking about what we're willing to pay to avoid climatic change. And in order to do that, we need a real precise estimate. So here, what we've done is we've taken all the studies of interpersonal conflict, and we've converted them to units of percentage changes per standard deviation in climate. Okay, and the reason we use standard deviation in climate is because climatic variations tend to be very different at different locations. And so we want to sort of calibrate this based on what the observed variation people expect to see. And we convert it to percentage changes because different types of violence have very different likelihoods of occurring sort of in baseline. So we don't want to use counts. And so what we see is that when looking at interpersonal conflict, a 1 standard deviation change, which is actually something that's not so uncommon, tends to lead to a roughly 2.5% to 4% increase in interpersonal violence, sort of as our global best guess, but we do get higher estimates as we go to sort of lower income populations. This is for when we look at intergroup conflict, there's actually many, many more studies. And what we find is sort of an average and a median estimate in the vicinity of about 12 to 14% per standard deviation, which is actually a much larger change in risk, but it's important to point out that these are much less common events. Civil war, civil conflict are much less common than interpersonal violence. Just for a sense of scale, in the United States alone, on an annual basis, there's roughly 2 million violent crimes. So if we talk about increasing that rate by a few percentage points, that's a large number of individual crimes that we're talking about. So now taking these numbers and thinking about the future, we're hesitant to make sort of very concrete projections because there are many things about society that we expect to change over the next several decades. But what we've done here is we've taken output from sort of a business as usual scenario, and we've scaled it according to the local standard deviation in temperature. And what you see is that around the world, in most inhabited regions, temperatures are expected to increase by 2 to 4 or 4 plus standard deviations. And so when held against the backdrop of these results, where you get about roughly a 4 to a 14% increase per standard deviation, this would suggest sort of some very careful thought about the extent to which future climatic variations could produce sort of more human conflict. So our sort of main conclusion is that to date, there's been an explosion of empirical research, and it is remarkably consistent. So for an example, there are 27 modern empirical studies of just looking at the effects of temperature. And of all those 27 studies, all 27 of them suggest that there's a positive association. So higher temperatures lead to more conflict. To get a sense of whether or not that's something that could happen by chance, you could think about flipping a coin 27 times and asking how likely it is that you would get 27 heads in a row, okay? It's very unlikely. The results for rainfall are slightly less consistent, but they are still strong nonetheless. And importantly, the quantitative magnitude of these effects, the last numbers I was showing you, are sufficiently large that we think that this impact has real policy relevance, and it's something that we need to consider carefully. Importantly, what we do not conclude is that climate is the only cause of social conflict. Obviously, human conflict is very complex. There are many factors playing a role, and the climate is only one of those. It's a contributing or sometimes amplifying factor, but it's not by any means explaining the vast majority of what we observe in terms of human conflict around the world. And so, in this study, what we've pointed out, there's really strong systematic evidence of a linkage between these two things, A and B, but we still have yet to figure out exactly how they're connected, okay? None of the statistical studies so far are able to point to any one of those numerous hypotheses I showed you on the first slide. And so moving forward, the main task is going to be to identify what is the particular pathway that's acting here, because we need to understand what the mechanism is if we're going to try to use policy to interfere and reduce these responses to reduce the effect that that climate has on human conflict, because obviously that's a positive social objective. Thank you very much.